Hello everyone, my name is Suhas. I am studying second year MSc. My presentation is about reinforcement learning and subtopics like semi-supervised learning, criteria functions for clustering, similarity and dissimilarity measures. Now let us define what is reinforcement learning. Learn to make sequential decisions in an environment to maximize some notion of overall rewards acquired along the way. It is a simple machine learning problems have a hidden time dimension which is often overlooked, but it is crucial to production systems. Reinforcement learning incorporates times or an extra dimension into learning, which put it as much close to the human perception or artificial intelligence. This is the diagrammatic representation of reinforcement learning, where we input some raw data. It will be covered with environment, reward, state, agent and selection of algorithm, and it will give best action as an output. Now we can take an example of setting and mouse and a maze with walls, food and electricity, and mouse can move its left, right, up and down, and mouse wants the cheese but not electric shocks, and mouse can absorb the environment. Here mouse is an agent and the maze with food and electricity is called environment. Mouse can move anywhere, that is called an actions. Mouse wants the cheese but not electric shocks is equal to rewards. Then mouse can absorb any environment, it's called observations. Now we can easily define what is reinforcement learning. Learn to make sequential decisions in an environment to maximize some notion of overall rewards acquired along the way is called reinforcement learning. Here we are taking mouse as an example. In simple terms, the mouse is trying to find as much food as possible while avoiding an electric shock whenever possible. The mouse could be brave and get an electric shock to get to place with plenty of food. This is a better result than just standing still and gaining nothing. What don't we want the mouse to do? We do not want to have the best actions to take in every specific situation, too much and not flexible. Find a magic set of methods that will allow our mouse to learn how to avoid electricity and gather as much food as possible. We can also say that reinforcement learning is precisely this magic toolbar. Now, let us talk about the types of reinforcement. There are two types of reinforcement: positive reinforcement and negative reinforcement. Positive reinforcement is defined as when an event occurs due to a particular behavior or increases the strength and the frequency of the behavior. In other words, it has a positive effect on behavior. Now let us know what are the advantages of positive reinforcement learning. It maximizes performance, sustained change for a long period of time. Now the disadvantage of positive reinforcement learning is too much of reinforcement can lead to overload of state, which can diminish the total of negative reinforcement. Negative reinforcement is defined as strengthening of a behavior because a negative condition is stopped or avoided. Advantages of reinforcement learning: increases behavior, provide defense to minimum standard of performance. Disadvantage of reinforcement learning is it only provides enough to meet up the minimum behavior variance protocol. And the application of reinforcement learning is RL can be used in robotics for industrial automation. RL can be used in machine learning and data processing. And it can be used to create training systems that provide custom instructions and materials according to the requirement of students. RL can be used in large environments in the following situations. The examples are a robot cleaning my room and recharging its battery. The robot unsucker. How to invest in shares. Model in the economy through rational agents. Learning how to fly a helicopter. Scheduling plans to the destination. These are the examples of reinforcement learning. Now, the challenges of RL. Observations depend on the agent actions only. If the agent decides to do stupid things, then the observations will tell nothing about improving the outcome. It's the only negative feedback of RL. Now, the agents need to not only exploit the policy they have learned, but to actively explore the environment. In other words, maybe by doing things differently, we can significantly improve the outcome. This exploitation dilemma is among the open fundamental questions in RL and in my life also. Now, reward can be derived from actions. Example, in cases of chess, it can be one single strong move in the middle of the game that has shifted the balance. Now let us move on to RL formalisms and relations. It has an agent, environment, communications channels like actions, rewards and observation. Now let us know what is an reward. Reward, a scalar value obtained from the environment. It can be positive or negative, large or small. The purpose of the reward is to tell our agent how well they have behaved. Then reinforcement is also equal to reward or reinforce the behavior. Now the examples are cheese or electric shock. Rates are a reward system to give you feedback about your paying attention to me. Now then we talk about the agent. An agent is somebody or something which interacts with the environment by executing certain actions, taking observations and receiving eventual rewards for this. In most practical RL scenarios, it's our piece of software that is supposed to solve some problems in a more or less efficient way. Example, U. Environment. Everything outside of the agent is called environment. It may be an universe. The environment is external to an agent and communications to and from the agent are limited to rewards, observations and actions. Now let us move on to actions. Things the agents can do in the environment can be moves allowed by the rules of play if it's some game. Doing homework in the case of school. They can be simple such as move pawn one space forward or complicated such as fill the task form. It could be discrete or continuous in form. Semi-supervised learning. It is an approach to machine learning that combines a small amount of labeled data with large amount of unlabeled data during training. Semi-supervised learning falls between unsupervised learning and supervised learning. This is the schematic representation of semi-supervised learning. Then, how semi-supervised learning works? The way that semi-supervised learning manages to train the model with less labeled training data than supervised learning is by using pseudo-labeling. This can combine many neural network models and training methods. Here's how it works. Train the model with a small amount of labeled training data just like you would in supervised learning until it gives you good result. Then use it with the unlabeled training data set to predict the outputs, which are pseudo labels. Since they may not be quite accurate, link the labels from the labeled training data with the pseudo labels created in the previous step. Link the data inputs in the labeled training data with the inputs in the unlabeled data. Then train the model same way as you did with the label in the beginning in order to decrease the error and improve the model's accuracy. Now we are discussing about semi-supervised learning algorithms, self-training, generative methods, mixture models, draft-based methods, code training, semi-supervised SVM and many others. Now we can talk about the applications of semi-supervised learning. A common example of an application of semi-supervised learning is a test document classifier. This is the type of situation where semi-supervised learning is ideal because it would be nearly impossible to find a large amount of labeled test documents. This is simply because it is not time efficient to have a person read through entire test document just to assign it a simple classification. So, semi-supervised learning allows for the algorithm to learn from a small amount of labeled test documents while still classifying a large amount of unlabeled test document in the training data. Now, let us talk about the criteria functions for clustering. Cluster examinations isolates information into bunches or clusters that are important, valuable, or both also. In case of significant bunches, are the objective at that point clusters thought to capture the common structure of the information. Now, there are three types of clustering criteria functions. They are internal triation functions, external triation functions, and hybrid triation functions. Now let us talk about the internal criteria functions. This class of grouping is an intra-cluster view, internal basis worth, applied capacity, and measure the nature of bunching capacity different groups which are unique in relation to each other. Now, hybrid criteria function. This work is utilized because it has the capacity to at the same time optimize numerous person model capacities, not at all like as inside basis work and outside basis work. Now the last one, the external criteria functions. This lesson of clustering measure is an inter-class view. External basis works optimizes a work and measures the quality of clustering capacity of different clusters which are diverse from each other. Now let us move on to last topic of mine presentation, similarity and dissimilarity measures. Now let us define what is similarity. The quality or state of being similar or likeness, resemblance as a similarity of features. Similarity is hard to define, but we know it when we see it. The real meaning of similarity is a philosophical question. We will take a more pragmatic approach. Now, the similarity is a numerical measure of how alike two data objects are. It is higher when objects are more alike. It often falls in the range of zeros and ones. Examples: cosine, Jaccard, and Tanimoto. Now, we are moving on to dissimilarity. It is a numerical measure of how different two data objects are. It will be lower when objects are more alike. The minimum dissimilarity is often 0 for the dissimilarity, and it also upper limit varies. The proximity is refers to in similarity or dissimilarity. Now, the measures of distance in data meaning. Clustering consists of grouping certain objects that are similar to each other. It can be used to decide if two items are similar or dissimilar in their properties. In a data meaning sense, the similarity measure is a distance with dimensions describing object feature. That means if the distance among two data points is small, then there is a high degree of similarity among the objects and vice versa. The similarity is subjective and depends heavily on the context and application. For example, similarity among vegetables can be determined from their taste or size or color, etc. Most clustering approaches use distance measures to assess the similarities or differences between a pair of objects. The most popular distance measures are used are Euclidean distance. Euclidean distance is considered the traditional metric for problems with geometry. It can be simply explained as the ordinary distance between 2 points. It is one of the most used algorithm in the cluster analysis. One of the algorithms that use this formula would be K-mean. Mathematically, it computes the root of square differences between the coordinates between two objects. This is the figure of representing Euclidean distance. Then, let us move on to Manhattan distance. This determines the absolute difference among the pair of the coordinates. Suppose we have 2 points, P and Q. To determine the distance between these points, we simply have to calculate the perpendicular distance of the points from x-axis and y-axis. In a plane with P at coordinate x1, y1 and Q at x2, y2, Manhattan distance between P and Q is equal to modulus of x1 minus x2 plus modulus of y1 minus y2. In this diagram, the total distance of the red line gives the Manhattan distance between both the points. Now let us move on to Jaccard Index. The Jaccard distance measures the similarity of the two data set items as the intersection of those items divided by the union of the data items. J of A comma B is equal to modulus of A intersection B divided by modulus of A union. Minkowski distance. It is the generalized form of the Euclidean and Manhattan distance measure. In an n-dimensional space, a point is representation as h1, h2 to up to hn. Consider 2 points P1 and P2. P1 is h1, h2 to hn. P2 is y1, y2 up to yn. Then the Minkowski distance between P1 and P2 is given as when P is equal to 2, Minkowski distance is same as the Euclidean distance. When P is equal to 1, Minkowski distance is same as the Manhattan distance. Now the last one is cosine index. Cosine distance measures for clustering determines the cosine of the angle between two vectors given by the following formula. Here theta gives the angle between two vectors and AB are called n-dimensional vectors. If you have any question, please drop your question at your comment box. First of all, thank you Jyoti ma'am for assigning me to represent this wonderful topic. Thank you one and all guys.